Question number 5. So question number 5 wants us to use information that's given and the graph that's given to answer the question. All right. So we're going to interpret what the graph is representing in relation to this context. All right. So let's go ahead. Let's begin. So the question says, Tamkia, all right, or Tamkika, all right, throws a ball up in the air. The graph below shows the height in h in feet as a function of time t seconds. How long, so this is where the question starts, how long is the ball in the air? All right, so that is the main question. How long is that ball in the air? Okay, so let's go ahead and try to use our graph to help us to understand this. Okay, so it says Tamkika, which is this person right here, all right, she kicks a ball up in the air, all right, but we know that the ball does not stay in the air. At some point it has to get back to the ground. So let's call this where she's at the ground level. So she kicks the ball up in the air, all right, it's still in the air up until 1.5 seconds, okay, because again x represents the time in seconds, okay? So this x right here is 1.5, okay? So she's in the air, the ball is in the air up until 1.5 seconds, but the ball gets to its highest point, okay, which we can call our vertex, all right? So this highest point right here is called your vertex. But then it starts to go down. So it starts to go down right back to the ground. So how long was the ball up in the air? So it was up in the air for about a total of 3 seconds, all right? Because how long means time, all right? So again, the ball was in the air from when she kicked it, all right, till when it got back down to the ground, and that's a total of 3 seconds, all right? So we're looking at the x, okay? So when it says how long, all right, so when it says how long it was in the air, it was in the air for 3 seconds, all right? And that would be the answer for this question. However, what if the question asks you a little bit more? So what if you saw something a little different, all right? What if it asked you, when she kicked the ball, where is it increasing? Well, to figure out where it's increasing, so again, she kicked the ball from here, all right? We saw that the ball went where? It went up. So on this side where it's going up, it is increasing, all right? So on this side where it's going up, it's increasing. And then we got to the vertex, all right, which is where all points meet. And then what happened on the right side? On the right side, we started to go down, all right? So we started to go down, what are we doing? We're decreasing, all right? So on this left side, we see that she kicked the ball and it was going up in the air. So it was increasing in the air until we got to the vertex, and then it started to decrease, all right? So this involves a lot of interpretation, okay? So I would say on the interval where she's increasing, so if I wanted to depict where she's increasing, we would say that she started the increase when she was at 0, okay? And then she stopped increasing at 1.5, all right? That's where the x value or the time value is, all right? So she stopped increasing at 1.5, okay? Because we're looking from left to right, that means we're looking at what values? The x values. So you put an x in the middle, all right? And then 1.5 is bigger than 0, so it would be facing the 1.5, all right? So the operator, all right, would be facing the 1.5 because 1.5 is bigger than 0, all right? What about when it's decreasing, all right? So let's look at when it's decreasing, all right? So when it started to decrease right here. So it started to decrease when your x was 1.5. That's when it started to decrease, okay? And then it stopped decreasing at this point, right, guys? So it stopped decreasing when x was 3. So it stopped decreasing when x was 3. And again, we're looking from left to right. So we're looking at the x values. And which one is bigger, 1.5 or 3? 3. So your operator or your sharp mouth faces the 3. All right. So your operator faces that 3 because 3 is bigger. All right. What if it asks you a little bit more, guys? Because this question has a lot of different ways that they can ask you questions. All right. What if they ask you, what is the time at its highest point? So again, what if it asks you for time at highest point? All right. So time at highest. All right. So to figure out the time at its highest point, we need to first find the highest point or its peak. All right. Because the peak is another name for highest point. So again, we're looking for peak. Okay. So again, if this is like a mountain, for example, where would the peak of it be? At the top, all right? So this vertex coordinate is where the peak is at, all right? To find the time at its highest peak, we're looking at the x value of that vertex because x represents time, all right? X represents time, okay? So the time when it's at its highest point will be the x value of the vertex, all right, which would be 1.5 seconds, all right? So at 1.5 seconds, it was at its highest point, all right? That's where it's at its peak. And again, the x represents the time, and then the y would represent the height. So again, in this case, for the 1.5 and the 36, the 1.5 represents the time at its highest, okay? And then this would represent the height at its highest, all right? So height at highest, all right? Or height at the peak, okay? Because again, the highest point is another name for peak, okay? So again, guys, I'm trying to give you all the information you might need, okay? So again, what if it now asks you what is the greatest height or the height at its peak, okay? What would the greatest height or the height at its peak be, guys? The greatest height or the height at its peak, all right, would be 36 because that's where it's the highest point, all right? And again, the y value represents that height, okay? So the greatest height would be at 36, all right? So what if it asks you a little bit more, guys? Because I want to give you all the information you might need. What if it asks you for the initial height, all right? So again, I'm going to write it over here to the left side. What if it asks you for the initial height, all right? Well, the word initial, another name for it, is your starting point, all right? So your initial is where you're starting, all right? And where did she start out kicking the ball? She started kicking the ball right here, all right, at 0, okay? So again, she started kicking the ball right down here at the ground, so that means her initial height is at 0, all right? What if it asks you for more, guys? Because it could ask you for what the vertex might mean, all right? So say it asks you what the vertex means. Well, the x value or the x coordinate of a vertex, all right, represents the time. So again, the x coordinate of your vertex represents time, okay? So for me, the x value of my vertex will be 1.5. So that time would be 1.5, all right? And that's 1.5 when you're at its peak, because again, the vertex is the peak, all right? So this would be 1.5 at its peak, all right? When you see it on Delta Math, you'll understand why I wrote this, okay? And the y value of the vertex or the y coordinate of the vertex, okay? So the y coordinate of the vertex, okay, so I want to write all the information you might need. All right, would represent, so the y coordinate of the vertex would represent your greatest height, all right? So again, this would represent your greatest height, okay? So in this case, what was my greatest height? What was my highest point? At 36, all right? So again, that would be everything you'll need to know for this question, all right? So let's try the next one, guys. So the next one says a skydiver jumps out of a plane, all right, from a certain height. The graph below shows the height h in feet as a function of time t seconds. What is the skydiver's initial height? So let's use the example here. So initial is where we're starting. And if we're saying the plane or the skydiver is here, because again, the skydiver has to jump from in the air. So the skydiver would be up here. So they're jumping off. Okay, they're jumping off in the air. Okay, so at what height did we start at? So again, x represents time. And the y represents, you know it, the y represents height. All right. So my initial height that I will be jumping from would be this height right here. All right. So the answer for initial height, all right, would be 9,216. All right. So that would be the initial height. Okay. And that is the answer. So use this example to help you to understand all the different things you need to look for.